Hello guys, welcome back to our studies on calculus. Today's lesson is on implicit differentiation. So here we are going to understand the concept of implicit differentiation. What is implicit differentiation? What is the meaning of it? In explicit function, y is written directly in terms of x. So when we say a function is explicit, it means that y is directly written in terms of x. Y has been made the subject. Now, example of explicit function is what we see here. Y equal to 3x squared minus 2x plus 5. When we come to implicit functions, it means that x and y are mixed together and cannot be separated easily. So the separation of x and y becomes difficult. Example, we have x squared plus xy plus y squared equal to 7. So this is an example of implicit functions. Why do we have to differentiate and implicit expressions or functions? So why use implicit differentiation? To find dy dx when it is hard or impossible to solve for y explicitly. So we use differentiation. We differentiate implicit functions to find our dy dx. If y becomes difficult to make it the subject or to solve it explicitly. So here, it is very essential when differentiating equations like circles, ellipses, and other curves. So circle, ellipses, and other curves have a function or equation where there is a mixture of x and y, which the y and the x cannot be separated easily. So now let's get to the steps to follow to differentiate implicit functions or equations. So here, the first step is to differentiate both sides of the equation with respect to x, which means we have to take the x as our independent variable. Good. Then we also have to remember that when differentiating terms with y, that is dependent variable, which is the y, we treat it as a function of x and apply the chain rule. So how do we apply the step 2, the principles of it? We have dy over dx of y. It means we are going to differentiate y, where this y is dependent variable. So if we are differentiating y, the results will be dy over dx. And we can also differentiate y squared, which is y being the dependent variable, as 2y dy dx. Here, we just need to apply the power rule of differentiation and also multiply the results by dy dx. And we can also try another example of trying to differentiate y raised to the power 3. So the derivative of y raised to the power 3 with respect to x will be 3y squared dy dx. So which means that generally for step 2, if I want to differentiate y raised to the power n, then the results will be n y power n minus y 1, n minus 1 dy dx. So here the step 3 is saying that we need to treat expressions such as xy, x raised to the power ny, x raised to the power n, y raised to the power n, and others as product, hence use the product rule. So it means that anytime you see a product between the x and y in this form, you have to treat this expression as product. Then it means you are going to apply the product rule. Then group all dy dx terms on one side. So group them at one side. It's like grouping like terms. Then factor and make dy dx the subject. That is the 5th steps to follow. So here we have a common use cases and equation. So the common use cases, or where we apply the implicit differentiation, are equations like x squared plus y squared equal to r squared, x squared plus xy plus y squared equal to 5, and sin xy equal to x plus y. Normally, it's about the equation of a circle, ellipses, and curves. So let's see an examples of this particular studies. So we are going to have implicit differentiation examples. So first we have to differentiate a function or an expression of the form x squared plus y squared equal to 25. So for the steps, this becomes the solution. So first we need to differentiate them term by term. So the derivative of x squared will be 2x, and the derivative of y squared will be in the form 2y dy over dx. Then the derivative of the constant 25 will be 0. So the next thing is to sum all the results together, which will be 2x plus 2y dy over dx equal to 0. So what are the next steps to follow? We just have to group the term containing dy dx at one side in a positive form. So here it has been grouped into this expression or this format. So here we have 2y dy over dx equal to minus 2x. Since I am interested in dy over dx, I'll divide both sides by 2y, as you have seen here. Then my dy dx will be equal to minus x over y. The 2 and the 2 will cancel each other. So this is the solution for the first example in a stepwise form. Now let's move to another example where we are supposed to differentiate x raised to the power 3 plus y raised to the power 3 equal to xy. So the solution for this problem or this question will be to differentiate each of the term in a separate form. So we are going to differentiate x cube as d of the x of x cube. Our result is going to be 3x squared. Then we differentiate the y cube, which will give us 3y squared dy dx. Remember, we are going to also differentiate the xy, and it is a product between x and y. So we are going to treat both this expression as product and apply the product rule. So doing that, it will be dy dx of xy equal to, in product rule, we maintain the first function, differentiate the second function, and also maintain the second function, differentiate the first function. At the end, our expression or differentiation will be x. When you differentiate the y, you get dy dx plus maintain the y. When you differentiate the x, you are going to get 1. So we do substitute our results in the as it has been done in the expression. So we have 3x squared for the derivative of x cube plus the derivative of y cube being 3y squared dy over dx, which is equal to the derivative of xy, which is x dy over dx plus y. Then we group the term containing the dy dx in a positive form. So we maintain this, then bring this 3y squared dy over dx across the equal sign, and it will now change to be negative. So here we factorize dy dx outside, then put the rest of the expression in a bracket as you see here. So that will be x minus 3y squared in a bracket. Then the next thing is isolate the x minus 3y squared from the dy over dx. We do so by dividing both sides by x minus 3y squared as you see here. So here we divide each side by x minus 3y squared. Then our final expression will be dy dx equal to 3x squared minus y divided by x minus 3y squared. So that is the answer for the example 2. Now, let's move to example 3, which looks a little bit complex. Here, we are going to repeat the same process, differentiate each respective term. So here, we will differentiate the x cube, and the derivative of x cube will be 3x squared. Then we also differentiate the 4xy squared. Here we are going to treat it as a product. So it will be, we are going to apply the product rule to differentiate this. And it states that we have to maintain the first function, that is the 4x, then differentiate the second function, that is the y squared, plus maintain the first function, that is the second function, y squared, then differentiate the first function, that is 4x. When we do that, our results will be, whenever you maintain this, we have the 4x here, and when we differentiate the y squared, we are going to get 2y dy over dx being put in a bracket, plus we maintain the y square here, is it, then differentiate the 4x, and our results will be 4. So when you simplify this, we are going to end up with 4 times 2 being 8xy dy dx plus 4y squared. Then we move to the next constant, which is minus 7. Then we differentiate the minus 7 with respect to x, and our results will be 0. We also move to the last end, which is y cube, and we differentiate the y cube with respect to x, and our results will be 3y squared dy over dx. So here we put all the results together, then group the dy over dx at one side. So we have the 3x squared here, the 8xy dy dx plus 4y squared being substituted as a derivative for the xy squared, then the 0 as a derivative for the minus 7, then the last end y power 3 will be 3y squared dy dx. Then we group the dy dx at one side in a positive form as you see here. Maintain this one, then we bring this positive 8xy dy dx across the equal sign, which will now tends to be negative. Then the next thing to do is we are interested in dy dx, so we factorize this dy dx outside the bracket. And when we do that, we end up with an expression of the form dy dx, and the bracket will be 3y squared minus 8xy. Then the rest at the other side of the equation. So we have to isolate 3y squared minus 8xy from the dy dx. Doing that, it means we need to divide both sides by this expression. Then our final expression or answer will be dy dx equal to 3x squared plus 4y squared divided by 3y squared minus 8xy. Now we move to example 4, where we are going to evaluate dy dx at a point on a curve. So we have to find the value of dy dx at the point -1, 1 on the curve. So this is the equation or the function of the curve. So we have to apply the same principle of differentiation, where we differentiate each of the terms of the functions. So here we have to differentiate the 2x cube, 3xy squared minus y cube plus 6. So doing that, the differentiation will be in this particular expression. That is, we are differentiating each term. So here we have 2 times, maintain the 2, then differentiate x cube will be 3x squared, plus we treat this one as a product. That is the reason why it is in a bigger bracket. So maintain the 3x, differentiate the y square. And when you do that, we are going to get 2y dy over dx plus maintain the y square, differentiate the 3x, and the derivative of 3x will give us 3 minus, then we move to the next term, we differentiate it as 3y squared dy dx. We move to the next term, differentiate a constant, and that will be 0, and differentiate another constant to be 0. So here we expand the bracket, then we have our results to be 6x squared plus 6xy dy dx plus 3y squared minus 3y squared dy dx equal to 0. We group the y dx at one side of the equation. So now the next thing to do is to group the dy dx. And when you group them, we are going to also factorize dy dx outside, and the expression in the bracket will be 3y squared minus 6xy. Then we isolate this expression from the dy dx, and this will be our results. But remember, the numerator we can factorize 3 out from the numerator and do the same to the denominator. When we do that, this is how the expression is going to be. 3 will be outside, and inside will be 2x squared plus y squared divided by y squared minus 2xy. Then the 3 and 3 will cancel. So the next thing to do is to write our final differentiation of dy dx in this form. But we are supposed to find it at the point where dy dx at the point of minus 1, 1. That is, x is minus 1, y is 1. So we do substitute x as minus 1 and y 1 in each of the terms, then simplify both the numerator and the denominator for us to have our final results as 3 over 3, which dy dx at the point minus 1, 1 is equal to 1. So this is a practice session for you to try your hands on and send your results to us for us to go through it for you. Continue to receive the best of high school maths understanding from this particular channel. Thank you.